Hi, I'm Aslı. I'm recording this video for the homework 1 of the ML machine learning course. This code defines a polynomial regression for implementing polynomial regression. Polynomial regression is a type of regression analysis in which the relationship between the independent variable x and the dependent variable y is modeled as an nth degree polynomial. Here we import some modules. We use the NumPy library while editing our polynomial template. Define a class named polynomial regression. It has constructor, parameters degree and reg lambda. Degree of the polynomial regression default is 1. Regularization parameter default is this. Initializes attributes here. Self means self std like. Next method poly features. A static method that performs polynomial feature expansion takes two parameters x and degree, an input array x and expands it into polynomial features up to the specified degree. Degree an integer representing the degree up to which the polynomial features should be expanded. The polynomial features should be expanded. Returns an NumPy array containing the expanded features. This line calculates the number of observations in the input array. This initializes a matrix X poly filled with zeros. This matrix will be used to store the polynomial features. Polynomial properties are calculated for each degree and placed in the relevant columns. Finally, the function returns the matrix. Another method is fit. Its purpose is to train the model using the provided input data x and target values y. This is an array containing the input observations. This is an array containing the target values. Apply polynomial expansion to the input data. Compute mean and standard deviation for standardization. The polynomial features are then standards by subtracting mean and dividing by the standard deviation. A regularization matrix is created. The weights of the polynomial regression model are computed using the closed form solution with regularization. And now predict method. Its purpose is to use the trained model to make predictions for new input data x. Takes x parameter. Again, polynomial expansion and data standardization operations are performed. This step essentially calculates the weighted sum of the features. The calculated sum represents the predicted values for the given input data x. Squared error. This function is used to calculate the mean square error between two numpy arrays A and B. These are the two numpy arrays to compare. This function is commonly used metric to measure the amount of error between two sequences. A low MSE indicates similarity between the two sequences. And learning curve. This function computes learning curves, which are graphical representations of how a model's performance changes as the size of the training set increases. X train, Y train, X test, Y test, reg lambda, degree. These are the input parameters. The function returns two arrays containing mean squared errors. Two arrays return error train, error test containing mean squared errors. This line creates an instance of the polynomial regression class. This loop iterates over different sizes of the training dataset. I want to run this file here, but it gives an error even though matplotlib is installed. I often get errors like this when I do something with Python, so I can show here and here now. That's all I say.